And so we started here. So in this talk, we will cover basics of the wireless sensor network. And so here we have mainly 7 sections. So first we discuss about wireless networks. Not only the wireless sensor network, but wireless networks. And then we figure out and find out the difference between these wireless networks and wireless sensor network. That means sometimes the confusion comes into the picture whether this is the wireless sensor network or this is the other type of the network. We also covers the applications of the wireless sensor network. So these three, we can say some sort of created some background in wireless sensor network. Then after we covers the basics of the wireless sensor network or the components of the wireless sensor network, where node architecture, data aggregation, routing, and communication protocols. Especially, we covers much about the LoRaWAN protocols, and we also see the list of the network simulator. And finally, we comes to the one Python program for the wireless sensor network. So here we can see that wireless network. So these all are the wireless networks. So wireless sensor network is one of them, wireless ad hoc network, vehicular ad hoc network, wireless mesh network, wireless personal area network, local area network, cellular network, satellite network, and WMAN. So all these are the wireless networks, and wireless sensor network is the one of that wireless networks. So we comes to the definition of the wireless sensor networks. If we are very first that and we want to figure out that, okay, what is the wireless sensor network? So very basic definition of the wireless sensor networks is to consist a large number of small, low cost, low power sensor nodes are wirelessly connected with each other to a center node. Sometimes the center node is known as the gateway, sometimes it's known as the sync node sort of things. But one thing is common, that these rest of the sensor nodes are small in size, low in cost, and low power, so that we can deploy a large number of sensor nodes. If the cost is very high, then it is not possible, the deployment, a large number of sensor node deployment. And what is the role of these sensor or the environmental parameters for some action sort of things. So this is some basic definition of the wireless sensor network, if you can say here. Now we cover the difference between the wireless sensor network and mobile ad hoc network. So first we see the definition of the mobile ad hoc network. So mainnet or the mobile ad hoc network consists of the mobile nodes that can communicate with each other without the need of the fixed infrastructure. So since their name itself suggests that the mobility comes into the picture, but one unique thing is that they are not required any fixed infrastructure, and such as the centralized access point or the base station. So this is the beauty of the mainnet. They are without any center control, without any center base station. The nodes can communicate with each other. And these nodes are capable of forwarding the data to the others node, create a multi-hub communication to the reach to the destination or destination. So, say for example, in the sync node is the destination, some sort of things without any fixed infrastructure support. Now, as we already covered, the wireless sensor network definition is the sensor nodes that are distributed over a large area. Large area means some forest area or some building. So it depends on the deployment pattern, whether you are randomly deployed or deployed with a deterministic fashion. Some man-made effect is there in the deployment. So if you are the random deployed, then forest areas and other things are the good example. As we can go in the buildings and other thing where the manually we can deploy one after another. But in compared with the mainnet are designed to provide the communication between mobile devices or nodes that can move, such as the vehicles, such as cars, UAVs, smartphone. All these, if they form a group, they can communicate with each other, they can make the multi-hub communication, then we can say, yes, this is the mobile ad hoc network, which is also a wireless network, but not the wireless sensor network. Another major difference between these two, wireless sensor network and mainnet, is so wireless sensor networks typically have the static and predeterministic network topology. That means either you can go in the deterministic deployment or you can go in the random deployment. That means you have some network topology, you already fix a network topology. But mainnet, that is a dynamic, self-organized network topology. That means it is very robust. Very quickly they change their topologies because of the nodes are mobile and other things. So link creation, link maintenance is a tough in mainnet as compared to wireless sensor network. Now we go to another class of the wireless networks, which is the vehicular ad hoc network. So vehicular ad hoc networks enables communication among vehicles and between vehicles and the roadside infrastructure. So all these vehicles, they can communicate with each other, and finally they can also communicate with the roadside infrastructure so that they can communicate their information to the outside world. Now for communication over the roadside infrastructure, they use the Wi-Fi, cellular network, these type of communication protocols they can use for communicate whatever the vehicles, they collect the information to that roadside unit for surrounding infrastructures and other things. Now, wireless sensor network, as we already seen, the collect the data from distributed sensor nodes and to send the data to the center node or the base station. But the vehicular ad hoc network designed to enable the communication among vehicles and between vehicles and the roadside unit. Okay. This is the main difference between wireless sensor network and vehicular network. Yes, it is true that the vehicles in the vehicular ad hoc network more predictable and structured way than the nodes in the mainnet. That is very interesting difference between mobile ad hoc network and vehicular ad hoc network. Mobile ad hoc networks, nodes are free to move here and there, but vehicular ad hoc network, they follow some pattern of the mobility. So say for example, if we use the public transport, and if we are follow from A node to A source to the D destination, that means your shortest path is already predefined. So in that case, they have some structured way of the moving. So this is the main difference between vehicular ad hoc network and mobile ad hoc network. We go some little bit further advanced, then what is the difference between wireless sensor network and wireless mesh network? So wireless mesh network consists multiple wireless nodes are connected to each other in a mesh topology. That means they can connect it with each other directly and has huge number of links between nodes and node. And each node can act as a router, forward data packets to the nodes until they reach to the destination. So this is the main beauty of the wireless mesh network, as the name itself covers the mesh. So they form a mesh topology for communicating their data. Now we go in a little bit comparison point of view. So wireless sensor network, as we already seen the applications such as the environment monitoring, agriculture, industry automation. These are the applications of wireless sensor network. But wireless mesh network provides the wireless internet access, support applications such as video surveillance, voice over IP, online gaming. All these are the example of the wireless mesh network, because devices are connected with each other using the mesh topology sort of thing. And wireless sensor network usually support the star and the tree topology, where each node transfer data to the central gateway. And here we are not focused on the mesh topology. Otherwise, what's happened that the huge links are there, and wireless sensor network is not support such type of the large number of links as compared to wireless mesh network. So here they have the mesh network topology, multiple other nodes, and act as the router to forward the data. So these are some comparison between these networks. Now this is the final comparison: wireless sensor network and wireless personal area network. So WPAN is the personal area network, communicate with the devices that are in close proximity with each other, not so far so. That means they are within the few meters. So if you have a smart room sort of things, then definitely you need to make the wireless personal area network. So the range is very few meters, and these devices are very close with each other to communicate, such as the smartphone, laptop, wearable devices, smartwatch, all these gadgets, they can make a WPAN network, so that they can make the security, they can make the energy efficient, and they can make the less interference with others. All these things comes into the picture. So this is the main advantage of WPAN as compared to WSN, wireless sensor network. And we already seen the wireless sensor network star and tree topology, and sensor node transmit the data. Wireless mesh network use a point-to-point or point-to-multi-point topology. That means the devices can connect it one-to-one or one-to-many sort of things and can communicate directly inside. So usually wireless WAN network assume that so inside the building some smart home is there, smart infrastructure is there. At that time we can focus on WPAN type of the networks. This is not comparison between wireless sensor network and other wireless networks, but sometimes comes in the mind that what is the correlation between wireless sensor network and IoT, or what is the difference between these two things in what scale. So as we already seen that the wireless sensor network is a network of the sensor node that are deployed in the physical environment to collect the data about the environment. So physical environment, your forest area, physical environment may be possible, river water pollution monitoring, whatever the environment is there, that is there. But IoT is little bit, that means superset of the wireless sensor network, or we can summarize that wireless sensor network is a subset of the IoT. So IoT is the broad concept. They refer to the network of the physical devices. Whatever the devices are there, that is also the part of that one. Vehicles may be possible, also the part of the IoT. Infrastructure is also the part of the IoT, and other objects that are embedded with the sensor and network connectivity to enable the collect and exchange the data. So here, along with these sensor nodes, they also have the vehicles, they also have the infrastructure, they also have some softwares and other things. Everything is together that we can say, yes, this is the IoT sort of thing, not only the wireless sensor network. Say, for example, if I take an example for water pollution monitoring. So what is the wireless sensor network in that case? So wireless sensor network, your sensor nodes can monitor the water quality through the sensor. And these sensors are some sort of the temperature sensor, pH level sensor, dissolved oxygen is there. But if someone says that you need to make the IoT for the water pollution monitoring, in that case, we can say the IoT for water pollution can include the additional devices such as drone. How you can collect the river water monitoring. So you can, your sensor transmit your data to the drone, and drone can communicate your data to the further processing like this one. Or autonomous underwater vehicles to provide the real-time data communication. So in that case, we can say, yes, we need to go to the IoT directions because we want to use the other devices as well as some other softwares or other infrastructure support. But if wireless sensor network end up only is this level that they have the sensor node, they sense the environment and relay this information to the base station. So this is all about the comparison between wireless sensor networks and other existing network. That we already seen the other existing network, and also we have seen the wireless sensor networks and the IoT. Now we see that some applications of the wireless sensor network. Our wireless sensor network finds their application in various domains. We are not able to summarize in one slide even, but if we find out in our environment, in our nearby field, what applications are possible. So we find out these main 7 directions applications. One is the environment monitoring, such as the weather forecast, pollution monitoring, precision agriculture. All these are the environmental monitoring or environment monitoring applications for the wireless sensor network. So if any agriculture ground is there, such as here, this is the ground inside the campus, we deploy some sensor nodes for monitor the soil levels and other things. That is the example of the wireless sensor network for environment monitoring. Industrial automation is also an application of the wireless sensor network. So say, for example, predictive maintenance, that whether the item is available or not, they are perfectly in a given rack or not, what is the state of that item, whether they are damaged or not, like this one. So this maintenance and this monitoring is possible. Quality control is also possible, and energy management, such as the that means this is some cold storage monitoring sort of thing, where some sensors are there, whether they need such level of cold or not, like this one. So we can save the energy, some light switch and on and off automatically, like this one. Now we come to the healthcare. Healthcare also have the application, and the wireless sensor network can also use in the healthcare, such as the remote patient monitoring, fault detections, medical monitoring. All these are the healthcare related. So healthcare is not only for human but also for animal categories. So say, for example, have you seen that this cattle monitoring or dairy product monitoring and other things? That is also an example of application of the wireless sensor network, where we can use the wireless sensor network. A smart home, that of course this is very close in our area. So smart home and the buildings, whatever the buildings are there, numbers of applications for wireless sensor networks, such as the energy management. So you can switch on, switch off the fan automatically with the help of the some sensory data. Security, automatically the tagging and face recognition, other thing comes into the picture. And home automation, that means automatically your electricity consumption transmit and other things. Traffic monitoring and whatever the transportation is comes into the picture, intelligent transportation system. Smart parking is a very best example of this one, and road safety is there, where person they are perfectly moving or not, they are going in the right direction, they are going to use the over speed or not. All these are the examples or the use of the wireless sensor network. Military and defense, they also use the wireless sensor network, such as the border security. So border coverage, area coverage, that is our direction of the wireless sensor network, where we can use the wireless sensor network for the military purpose. And target tracking is there. If someone is crossed the border, they can automatically detect and inform to someone else. Finally, disaster, so that early warning sign of the earthquake and other things, or the tsunami sort of things. So that type of the applications in the wireless sensor network in day-to-day life in this category of the disaster management. rescue operations is also very helpful if you use the wireless sensor networks, and of course disaster recovery. So if you want to make the health of the structure after some earthquake and other things, then wireless sensor network play a major role in that case. So these all are the examples of the wireless sensor network that we can use in our day-to-day life and nearby. These are some sort of things that how we can use in intelligent transportation system. So this is a bridge structure monitoring. You can deploy the sensors, they can collect the information. If any vibration is more than the threshold value, they can automatically transmit this information to the sync node. So that no one is required the periodically or continuously monitoring, they automatically monitor and transmit this information. This is the water transportation. So whatever the boat are there in Varanasi region and other things, some of these boats, they use the pollution data, water pollution data, they can collect and transmit like this one. These are some vehicles, they have some sensors, so velocity of the vehicles, vibration, their direction change and other things monitoring. These are the road health monitoring, that whether this road is still perfect after some rainy season or not, like this one. And this is the some other type of the bridge structure monitoring, that what is the vibration level, what is the weight of the vehicles and other things. So all these are the applications of wireless sensor network in nearby region, whatever we find out here and there. Now, after if we identify that, okay, this is the wireless sensor network, not MANET or VANET and other things, and we also identify that, okay, what is the application? So if we have our applications, then how we can build a wireless sensor network, what components are required for making a wireless sensor network. So the 4 basic components are there. One is node architecture, whatever the node wireless nodes you are using, that is the very first component. Then how this node can data aggregate, that aggregation algorithms, protocols and other things comes into the picture. Then if aggregation is over, how to route this data to the sync node. And finally, what communication protocols are required for communicate this information to the sync node. So if we think about the deployment of wireless sensor network, we need to take care of all these 4 dimensions. So very first, we comes to the node architecture. So when we talk about the node, as we already seen that wireless sensor node, which is the small in size and low power consumption, because these are the battery powered. You are not able to change the battery, or you are not able to charge the battery very frequently, very periodically, such as the forest monitoring. You are not able to once again collect your node and replace or recharge your battery. So that means that whatever the nodes you have designed, that must be the low power consumption and energy efficient node, and also small in size, and autonomous devices are there. So say, for example, they automatically change their mode, that, okay, these are the normal, these are the power saving mode, or some vehicle monitoring in the night time is not required, only in the daytime is required. That means some intelligence, some autonomous devices automatic is required in that case. Now, if you open that node, if we, whatever the node is there, if you open that node, you can find out these main units. So this is the picture of block diagram of this wireless sensor node. So if you deploy this node, so like this one, this is a node and they have the 4 main unit. So if I open this node, one is the controller, which is also known as the processing unit. And they process the entire data, whatever the data is collected from the sensor, whatever the data comes from the other nodes, they process this data and they transmit this data using the transmitting units. So this is for transfer the data from this node to the another node. And how they can collect the data? With the help of sensing unit. So sensing unit, they have the sensors and ADC, analog to digital converter, and other units are there. So the sensors, they have the sensor, they collect the sensory data and transfer to the controller. Controller do some processing and use the communication or transmission unit to transmit this data to the others. Of course, the power source is required, such as the battery and other things, how they can take the powers and other things. Sometimes this is the some solar cell or solar batteries are there. So solar plate and other things are also the part of the power source unit, how they can do. Yes, of course, while we are doing the processing, definitely we need to use some temporary storage. So temporary storage or some external memory is required in 2 cases. One is that if you have some data, you process the data, your data collection speed is high as compared to processing speed, definitely you need to store the data in somewhere else. Another reason is that these are the relay based. That means the data comes from the other nodes to this one node, and this node can forward this data to the other nodes. Maybe possible these nodes collect the data from the various nodes. Then of course, their communication speed is not as fast as their collection. That means they collect a huge data. So definitely they need to store the data from somewhere else as a temporary. So memory is required for their own data, and the memory is also required for the data from the other sources. And finally, the clock is required, but the clock, sometimes clock is required, sometimes clock is not required, depends on your application of wireless sensor network. So when we require the synchronization, that means when you send the data, you need to time clock, and when you receive the data, time clock is required. If time difference is more than the threshold value, they discard these packets and other things. If such type of phenomena is there, then clock is required. Otherwise, the clock is not required. But initially, these 4 units are the main unit: sensing unit, processing unit, transmission or communication unit, power source unit, and the memory is required for store the temporary data and so. Right now, what else is there, that microcontroller itself is sufficient. They have the memory unit inside the microcontroller or nearby the microcontroller, like this one type of solutions are there. And clock is for synchronization or sync up these devices. These are some major players, industry players. They design or build the wireless sensor nodes, wireless sensor network nodes. And microelectronics, ST microelectronics, Texas is that means they have the numbers of sensor nodes in the low cost and high cost, and everything is there. Even they have numbers of sensor nodes for educational purpose. So that is very big series of the sensor nodes in this Texas. Silicon is there, Bosch is there, and Liblium is also there. They also have the numbers of agriculture, or these wireless sensor node kits are there for agriculture, for city monitoring, city pollution monitoring, smart parking kit, and other things. So these 5 are the major players, the companies, they product the wireless sensor network nodes. So if you want to purchase, then definitely we need to go to all these sites and check that, okay, which node is suitable for our own application purpose in terms of the cost, in terms of your requirement, whether you required a high energy, you required a small in size, you required very robust, all these things are there. So here in the picture, we can see that, okay, this node, they have the USB connection, and this node is powered by the 2 cells like this one. So all these are the requirement, that what requirement is there, we can pick the node and select the node. So definitely we need to go to these company sites to check that what is the availability is there. Now, so this is the node architecture that we have seen. They have the sensing unit, processing unit, communication, power unit, memory, and clock. So now we talk much more about the sensing unit. So here we have seen that the sensing unit has the sensors. So what is the responsibility of the sensing unit of a wireless sensor node? Of course, they need to detect, they need to monitor, they need to observe the physical or the environmental parameters. Okay, they need to detect the physical parameters, whatever the physical parameters is there, and the environmental parameter. Now, question comes into the picture: what is the difference between physical and environmental parameters? Of course, both things can detect with the help of the sensors. Sensor is always. But what is the difference between these two? So physical parameters sensing measures the physical conditions in a particular environment. So such as the temperature is the physical quantity, and the pressure means the gas pipeline. If more pressure is there, they can detect like this one. Humidity is the environment. Humidity in the moistures like this one in the soil and other things. And light intensity is also physical parameters. Sound level is also a physical parameters, and motion detection and other things. So all these are the physical parameter that is detected by the sensors, which are attached with the sensing unit in a node. But environmental parameter is also important, and yes, these wireless sensor networks are capable for detection of the environmental parameter and changes in the environmental parameter. So such as the air quality changes. So if change in the air quality, some pollution level is high or low, these are the environmental parameters. Water quality, soil moistures, and the radiation levels. All these are the environment nearby our environment, such as the air, water, soil, radiation level. All these are the environment nearby us. So these are the known as the environmental parameters, and they are detected by this one. So if you take an example that this physical parameter is the temperature sensor can use to measure the temperature in a room or the greenhouse. So here in this case, you need to measure the physical parameter. But if a gas sensor can use to detect the presence of the harmful gases in the air, so these are the air quality direction. This is the environmental parameters, not the physical parameters. So right now the sensors are exist for both type of the measurements or the measures. And here we can see that classification of the sensor, how we can classify the sensor, because the sensors are huge sensors are there. So we are not able to classify based on their name. So definitely we need to use some terminology for classification. So based on the sensing technology, how they can sense and what phenomena they use for sensing purpose. So if the sensor, they use the resistance for the sensing purpose, that means whenever some changes or the occurs inside the temperature or inside the environment, then definitely they can detect. So that means the resistance change related sensors is in that category goes in the resistance sensors. So such as the example is the temperature sensor. So whenever the temperature change, then definitely they can detect and they can inform this is the resistance. Or the light sensor, some light intensity is there, they can detect the light intensity and transmit this one. So these are the resistance. So whatever the resistance in the wire or resistance inside that one, if they change with the because of the temperature, because of some light, then we can put the sensor in this category. And the second one category is the capacitive sensors. They have some capacitance and change the capacitance based on the value. So say for example, humidity sensor or the soil moisture sensor. So that is they have the capacitor sort of thing. They store some values and measure that values like this one. So different from the resistance, they use the capacitor. That's why they go in this capacitor. Third one is very interesting. They use some coil sort of thing, inductive sensor, some proximity sensors. So they make some effect in this region. If someone obstacle comes within that effect, then they can detect. So this is the inductive effect or some coil measurement sort of thing. So these are the sensors, they are the inductive sensors. They can detect the proximity values with the help of this interference region. So if there is interference region created, if anyone obstacle comes within that interference, they can detect. Finally, that is the fourth one category is the optical sensors. So these are some optical diodes or photon is there, is some light intensity that goes on the photons, then they can detect. So these are the categories based on the sensing technology. So broadly, we can classify into sensor technology into four categories. One is the resistance-based, capacitor-based, induction, and optical sensors. And based on these categories, we can easily classify the sensor in a different way. Yes. Sometimes that literature, they say the sensor can deploy, can classify or divided into based on the perimeters they measure. So say for example, temperature sensor, they measure the temperatures, pressure sensor, humidity, light, sound, chemical, motion and proximity sensors. So this is their name itself. So here we are not using some, that means technology, we use what they are doing. So if they measure the temperature, say they're the temperature sensor. If they measure the pressure, we can say this is the pressure sensor. So this is the another class of the classification, and these are some pictures of the sensors that okay, this is the smoke sensor because they detect the smoke. Alcohol sensor, they use the alcohol sort of thing. So this is the touch sensor. So based on their application, we can name the sensor. Then we can say yes, these are the classification of the sensors. And right now, because of the low cost of the architecture, low cost of these type of the devices, these sensors are very cheap right now because the architecture is very cheap and very nano size. So the cost of these sensors are very less as compared to earlier. And that category. Now we go to the another class of the sensor classification. So some literatures, they say that no, based on the that means whatever the technology you have built, that is not a correct way, and or this one. So they divide it very easily into two categories. One is the analog, other one is the digital. If a sensor, they continuously transmit their data. They continuously transmit their data without any interrupt or without any delay. So in that case, we can say this is the analog sensor. Continuous values you find out. Of course, value is high or value is low. So say for example, light intensity sensor, they continuously transmit the light intensity. So sometimes sunlight is high, then their light intensity is high. If the sunlight is less, then definitely light intensity is low. So this is the continuous values are there. So such type of the sensor goes in the analog sensors. Other category or the different category, the digital sensors, they have only two state, either on and off. So proximity sensor is the digital sensor. So say for example, door open and close. So that is on and off. Okay, so if one sensor is for door open and close, that means in that case, we can say this is the digital sensor. Why? Because they generate only two values, binary value, 0 or 1, like this one. So this is a very, this is very easy that, this is very easy to classify that the sensor into the two categories. One is the analog sensor, other one is the digital sensor. Of course, based on their application, not based on their perimeter measurement. Here we measure the perimeters. Here we have the application. So if the sensor is useful for the environmental monitoring, then we can say these are the environmental sensors. So this is the another class of classification. If the sensor is useful for industrial purpose, we can say industrial sensor. If the sensor is used for medical sensing purpose, then we can say this is the medical sensor. So this is the application-based sensor classification. So these are the non-classification of the technique. So it depends on the, that means literature, it depends on your application that how you can classify. So, but that means most of the people, they say the sensor based on their name, that what perimeter they detect, we can take that sensors like this one. This is the last one classification, that a very interesting classification, that we can classify the sensor based on their resources, based on their, that means energy, whether they have some energy source or not. So active sensors, one is the active sensor, other is of course the passive sensors. So active sensors require an external source of energy to generate their own signals that is used to probe the environment. So this is the active sensor. They generate some sensor, the energy, and reflect back that energy, then they can detect the motion of the birds and other things. So active sensor, they have their own, that means external energy source for generate the signals, and based on the reflection, they can identify that whether some environment monitoring and other things. So radar, sonar, radar, all these are the that active sensors. So this type of active sensor, they have the power hungry. They need a huge energy because they are the, that means have the energy, then they can only generate the signal. So power consumption is very high in this type of the sensors. So if you deploy the such sensor in the forest area, then definitely the life of the wireless sensor network is very less, until unless you use the solar power and other things. If they are also have the solar plates and other things, then it is good. Otherwise, their life is very less as compared to passive sensor. Passive sensor, so passive sensor, they are not required any external source of energy, and they depend on the natural energy sources, such as the sunlight. And so when the sunlight is on the earth, then we can detect like this one. So these are the passive sensors. So here we have no such our own energy source. Whatever the energy source is the sun, they have the heat or they have the sunlight, then we reflect it and we can detect like this one. So image sensor or the camera sensor, infrared sensors was in this category, the passive sensor. So these are the classification of the sensors that based on their application, based on their technology, based on their working principle and all other things. So any question or yeah, can anyone can confirm that presentation is going on perfectly?
Yes, it is going on.
Yeah,
and I can also request all the center coordinators. So in between, if any student is having queries, they can interrupt and they can ask the question. And also you can write down the questions of students in the chat box as well, so that sir can also see it in between. Yeah. Thank you, sir.
Yeah.
So you can continue.
Yeah, please. So if anyone has any query, any suggestion or any point, then definitely they welcome them so that we can discuss at that point. So now we have seen up to the sensing unit. After the sensing unit, we comes to the processing unit. So assume the sensors is already there. Whatever the classification is there, you have the sensor. Sensor has the, if you have the sensor, then definitely you can detect the environment perimeters, or that is the perimeters. Now these perimeters or these values transfer to the controller. Not the controller, that is the processing unit, transfer to the processing unit. Now, the duty of the processing unit is to process the data, so that we can see that how it works. So the responsibility of the processing unit, the responsibility of this processing unit is to process and analyze the data collected by the sensor. So there are two things. One is the processing, other one is the analyze. Before that means the very first step is processing is required. Say for example, data pre-processing. Okay, numbers of values are there, some is very up, downs, noise is there, all these things are there. So, or some analog signals are there, some sort of thing. So need to convert into one form to the another form is the processing. And once they convert the data into one form to the another form, after that we can do the analysis. So both responsibility is the processing unit, process and analysis. So say for example, you have the wireless sensor network for forest fire monitoring. Fire, that means the temperature is more than a threshold value. So if some fire is there that 90-degree or 95-degree temperature or 100-degree, assume that whatever value is there. So processing, first they filter out the noise and other thing. Once they have noise-free data, then analytical or the analysis, they say that whether the temperature is greater than the threshold value or not. If the temperature is greater than the threshold value, this is a part of the analysis and not the part of the processing. So analysis says that yes, the temperature is the greater than the threshold value, then we can relay this data to the other nodes. Otherwise, we can drop this data. Why? Because that is the normal, there is no fire at all. Yes. So processing for pre-processing and other work, and then after comes to the analysis, whether it is required or not. If required, then we can do something else, we can drop it. So this is the responsibility of processing unit. Another responsibility of processing unit for managing the power consumption. The wireless sensor networks, as you already seen, that deployment in the forest area, deployment on the river and other things. And these nodes are the battery powered. Battery usually not replacement or rechargeable mechanism. So in that case, definitely whatever the battery is there, that is their lifetime of the node. And lifetime of the node directly impact the lifetime of the wireless sensor network. If some nodes goes down, then definitely black hole comes into the picture in forest area. Then you are not able to monitor. Then you are not able to successfully monitor in the forest fire. So battery goes down of the some nodes directly, indirectly, they can kill the wireless sensor network. They are not able to sense perfectly the entire region, and they are also not able to communicate this information to the sync node. If some hole is there, no communication sensor node is available because of the power. So power consumption, managing the power consumption is also a big responsibility of the processing unit. So how they can reduce the power consumption, this is their responsibility. So say, for example, if you take an example, analysis. So you can check that whether the temperature is more than the threshold, then only you can transmit this data. Else just drop it. So if we drop the data, we are not, we can save the communication energy, and whatever the power consumption by communicating this data, not only the communication energy of that node, but also the communication energy of the relay nodes. So this is the responsibility of the processing unit. So whenever you select a processing unit, whenever you burn your code in the processing unit, you need to worry about processing, what pre-processing is required, what analysis is required for power saving. Another example of the power saving in the analysis is the data compression. So if you have the huge data, why you transmit without any compression? You can use some coding approach. So say, for example, if your data has a very long string, better you can convert in some hash table sort of thing. All these things work in especially for the power consumption, especially for the analysis purpose. Yes, as we already seen that the communication. So responsibility for communicating the analytical data with other nodes. So as we already seen that if you, that means this the processing unit is the responsibility for communication. If your data size is very big, your data string is very large, and your communication protocol speed is very less, that means they support only some bit per second or byte per second like this one, okay, BBS like this one. So in that case, this is the responsibility of processing unit to compress the data before transmission of data. Otherwise, processing unit, they break the data into multiple packets, and you can transmit these packets sequentially one after another. It's a huge communication overload. So the throughput goes down. So it is good that we can compress the data, we can filter out the data before transmission of the data. And who else can do? This is only the processing unit can do all these things. And processing unit also responsible, and they can also take care of the executing the source code or the software that control the behavior of the node. Here, behavior of the node is not only the related with the data, but also the health of the node, but also their structure or their state of the node. Say, for example, they have very limited battery power. Now they know that they need to survive next 5 days. They see that, okay, in the night time, I have very limited data. Why they are working on the night time? Better they can go in a sleep state in the night time and active in the daytime. Similar is the forest fire monitoring. Why they are detect each and every second data. If they see that, okay, my battery lifetime is very limited, residual energy is very limited, then what they will do, they can use some time window, more time window. So in place of each second detection of the temperature, they can detect the 30 minutes, 25 minutes, 20 minutes like this one, so that they can save the battery power and execution of. So these are known as the behavior of the nodes. That means they change their behavior, they change their sampling rate like this one. And these are not the behavior of the data or the behavior of the sensor. Sensor working their own, but the node, they change their behavior for detection. In place of 1 second, they can change in the 30 minutes and so on. And all these things done with the help of software, whatever the framework you have run on that node. So this is the responsibility of the processing unit to control that software or to change the software and other things in that case. Now, when you choose the processing unit, when you have the option that, okay, you can select this processing unit or that processing unit, what keep in your mind? So when you select the processing unit, when you go to the PCB board designing and other things, you already select the temperature sensor. Now we work on the processing unit. So first thing about the application. What application is there? Your application is some very crucial application, or this is the normal application. If the normal application, why you are selecting a high processing unit, which consumes huge energy, which cost is very high. So if your application is very normal, that means that is not a very crucial application, some not life and death matter like this one. So in that case, you need to select the process unit which is low cost, which is the simple, which consumes a very less energy. That type of processing unit we need to select in that case. And also that application is depend on the, that means requirement is select the speed of the node. Say for example, if your requirement is very high, that means you need to detect and you need to process, you need to analyze the data within a time sufficient time. Say, for example, that means soil moisture monitoring in the agriculture field. That means you have sufficient time. You are not very time crucial. So you can use the slow processors, whatever the processor, their speed is the slow, then that time we can select that type of processor. Power consumption is also there. So you need to select the processor which consumes less power, but don't compromise with your requirement. So if your requirement is high speed, if you select the processor which consumes very less power, very slow, then definitely. And form factor, that means what is the shape is there, what is the packaging and other things comes into the picture, or what is the size is there, whether this node or this process unit sufficient size or very bigger size that is not put inside your devices, then nothing to be useful. So these type of factors you also need to consider when you select the processing unit. Now in the wireless sensor network, types of the processing, similar as we have seen the types of the sensors. So processing units also have the different types. And of course, the types depend on various factors. So very first, a very simple, a very small is the microcontroller. Okay, this is very first, that means very simple, which is small in size, very low cost, low power integrated circuit. They contain a microprocessor, a small memory, very small memory, and some other component, whatever the components are required. So this is an example of the microcontroller. They are the microcontroller. And they are commonly used in the wireless sensor network due to the low power consumption and small in size, and also because of the low cost. So an example is the Arduino. So as you already, that means you all know about the Arduino board. So they have the microcontroller. And this is a small size, power consumption, integrated circuit, all these properties are there. Now we go in a one step advance. So every time this type of the low processing, small size, very slow is not sufficient for your application. Then you need to go to the DSP, digital signal processors. So in that case, whatever the nodes are there, you need to put the digital signal processors. So these are the specialized microprocessors, not a normal microprocessor, that is for application purpose design or driven microprocessor that are designed to perform the fast, efficient calculation on the digital signals. Calculation is here based on your application. So various, that means microprocessors are there, or based on their application. Commonly used the this type of the digital signal processing, the micro wireless sensor network required signal processing capability, such as audio and image processing. So say, for example, if you want to use some nodes for tiny machine learning sort of thing, or some prediction based on the image or based on the audio, this type of Arduino or this type of the microcontroller is not sufficient. Then definitely you need to go to the digital signal processing type of the board. So SensiBLE is an example of the, right now, it's a very well known in this category of the digital signal processing. Its cost is also very less. And it is a good example of using a little bit more advanced in the microcontroller, that is the digital signal processing. They also perform some signal processing capabilities, whatever the requirement is there. We go in a one step further advanced, that is this DSP is also not sufficient. In that case, you need to go to the field programmable gate array, FPGA. Okay, Lorenzo use this FPGA right now. This that IC, they have this. This is a programmable logic device that can be configured to perform the specific function, whatever the function is required. And the beauty of this solution is that high speed processing or customized logic gate. So whatever you required, that you can customize based on your requirement. And advantage is that high speed. So this is the third step. One is very small, then you can go to the microcontroller. Then if you use the signal processing such as audio, video, audio and images, video is a little bit high in wireless sensor network, usually not support, and audio and image is possible. So DSP, then we go to this FPGA, that is high speed and customized based on your requirement. So already available in the market. The board is already there. You need to attach the sensor and use it perfectly. Last and final is that is the SoC, system on chip. This is the complete system sort of thing, and an integrated circuit that combine the multiple component on the single chip. Because they also consume the low power consumption and small size in this one. And this is the example of STM32 is the example of the system on chip. So the difference between these two is that they have the multiple component, not only that processing unit, but also they have the other component in that case. So these are the 4 categories. Based on your requirement, you can select and use it. Now, how we can select not only the application, but also the other parameters also affect when you select which unit is suitable for my application. So based on the application requirement. So if you have the 4 options, all 4 options are available in terms of your budget, in terms of your size, in terms of your requirement. So what parameters we need to consider when we pick one out of these 4? One is the application requirement. What application is there? One is the processing speed. If you need a high processing, definitely you need to go to the low range. And you need a memory, you need a power consumption, or you need a signal processing and other things. So if you require the signal processing, then definitely you need to go to the digital signal processors, not the microcontroller. So this is depend on your application requirement. What application is there? Based on that one, you can select the unit. The second one is the power constraint. That means whenever you select that, definitely you need to worry about the power consumption. If you are not able to replace your battery, if you are not able to charge your battery again and again, so when you select, you need to worry about the power constraint, that how much power is there, what power sources is there. Another important is the available resources. What software library is there? Say, for example, if you use digital signal processing, and right now you go in the market and purchase in the other way, this one or that one, they are not support whatever the libraries you have built, whatever the software design you have designed, because your library requires some signal processing libraries also. So in that case, definitely you need to select the controller which support your libraries, not directly support based on their processing or based on their cost. And of course, the form factor, that means what packaging is there, whether you can put this unit inside that on the PCB or inside the bags and other things. So that is also an important factor that when we select this type. And test and optimization is that is the last one, that how you can configure your perimeters. Configuration of the perimeters, that means change the perimeters. So if your board is support to such type of the configuration optimization or not, if you required. So say, for example, if I need a dynamic perimeter changes in the communication protocol. So whether this type of the controller is support the dynamic changes, or that type of the controller is support the dynamic changes in the perimeters. So these are the some that means selection criteria that when you select a unit, what keep in mind. And apart from this, numbers of other criteria are there, but these are some criteria that is there. Form factors is also covers the high temperature and other things. So say, for example, if you use for that means fire monitoring. So fire is there, that means how your node can survive. So that is also the part of the form factor. And similar is the agriculture water resistance, that is also comes in this category. So you need to have your requirement that okay, water resistance and other thing that is there. So up to now in the node architecture, we have covered the sensors, that what is the sensor, what type of the sensor, classifications of the sensors and others. We have also seen the processing unit, how they can process the data, what data is there, how they can solve these problems and other things. Now we need to communicate this information to the node. We need to translate this information to the other nodes. So because of that reason, this node also have one communication or transmission unit to transmit this data out to and receive this data from the other nodes. So main responsibility of this unit is to transmitting and receiving the data wirelessly. Because we talk about the wireless sensor network, so wireless automatically comes into the picture. Here, interesting thing is that this unit is responsible for both transfer as well as the receiver purpose. Okay, someone is transmit, then I can receive this information. So the one single unit is there for transmission and the receiver purpose. And they consist of the radio frequency transmitter that can communicate with other nodes. So that means they have the fixed RF radio frequency for communication, for transmission of the data inside that one. And once you select or once you find out one unit, you need to keep in mind that the power consumption, that it consumes huge power. So whatever this antenna designing is, this is a PCB printed antenna in that chip like this one. So what power level is there? If the power level is more than what you are expecting, then definitely you need to select the other unit. what memory is required for storage, for communication, and for receiving and processing like this one. So all these things comes into this unit part, that how to select. We need to worry about all these power unit and other things. Now, feature of this unit is that means when we select or what features are required, what qualities of services are required in this unit is as follows. So here that is the communication protocol. So each node, they have communication capabilities, but they use the different communication protocols. Say, for example, some nodes, they support the Bluetooth, some nodes, they support the Wi-Fi like this. So when you select this unit, you need to check that which protocol is suitable for you. So that means specific or given protocol is specific. That means, say, for example, your other nodes, they support the Bluetooth, then definitely you need to use the unit which is the Bluetooth enabled. Otherwise, how you can communicate this information to the other nodes? So communication protocol is fixed with respect to the unit. So when you select a unit, when you work on the unit, you need to check that, okay, this unit supports whatever the communication protocols you are using, your other nodes already used in this protocol. Second is the frequency band. So these nodes, they have, that means this unit, they have the different frequency band, 2.4 gigahertz, 5 gigahertz, like this one. So the frequency band is the different. So when you select this unit, you need to worry about that, okay, whether this frequency band is suitable for you or suitable for your application or not. Sometimes that we go to the spectrum sort of thing. This is a license spectrum, this is a license-free spectrum, like this one. Another is the modulation technique. Since that node is the large node are there, if you are not using modulation technique, you are not able to transmit the multiple data simultaneously. So modulation, they change the format so that you can transmit the data simultaneously, and nodes can receive that, demodulate, and they can extract that information. So such as the frequency shift keying, FSK, or the PSK modulation technique, and change the data. But the important thing is that whatever the nodes are there, if two nodes they can communicate, they have the same modulation technique, then only they can detect, otherwise they are not able to work. So whenever we select the device, we need to worry about the neighbors. That means how we can share this information with the others. So modulation technique is same as the existing. Another important factor is the data rate. So if you generate a large data, if you attach the 10-12 sensor inside the node, definitely you need a high data rate unit. Otherwise, how you can transmit your data? That your memory is also limited. So after some time that data goes down. Why? Because your capacity of the communication is not sufficient. So in that case, your data goes down. So data rate is also an important factor when you select this transmission unit, and that must be able to transmit and receive the data at the required data rate for the application. But usually we assume that wireless sensor network, they have a very limited data. That means not a very huge data expectations in that case. But yes, they are able to. Last one is always the power comes into the picture. Every unit, they have the power constraint or power consumption, because the power hungry is nothing to be useful. Someone, they attach that means Wi-Fi or some other communication protocol in wireless sensor network, they consume a huge power, then that is nothing to be useful, because we are not able to replace the battery or recharge the batteries. Now, if we select the unit, then of course you already select a protocol, because the protocol is already there inside that unit, like this one. So if you select a one communication unit, and they support the Bluetooth, they support the Wi-Fi, they support the Zigbee, they support the LoRa, then definitely these are the protocols. So wireless sensor network, this is some of the selected protocols. So wireless sensor network, they support various protocols, and most of these nodes, they use these 5 protocols. So these are the communication protocols. When we transmit the data, definitely you need to follow some rules, you need to follow some that means set patterns, and these rules arranged in a hierarchy manner or in a fixed manner, then we can say this is a protocol. So when we make some rules and we arrange these rules in some order, then protocols comes into the picture, and the communication protocol. So very first is, we will see in details later on, but yes, IEEE 802.15.4, this is a standard, and numbers of protocols that depend on this or the based on this standard. And this standard is specially designed for low power wireless communication purpose. So especially for wireless sensor network, and these standards work on the 2.4 gigahertz frequency. And this is IEEE, of course, there. And then the Zigbee protocol comes into the picture. They use this standard. So whatever the bottom 2 layers, they use this standard IEEE 802.15.4. And since this standard itself is designed for the low power wireless communication, then definitely these Zigbee protocol, they also support the low power, low data rate, real-time application, such as home automation, switch on and switch off the light, smart lighting, street light and other thing, or industry control. But the Zigbee is the short range communication protocol. That means you can not communicate some kilometer sort of things. Then we comes to the Bluetooth, and then after we comes to LoRa. So Bluetooth, that is also another wireless communication protocols, and this is also low power wireless communication protocol, especially designed for IoT and wearables, and they support the 2.4 gigahertz frequency. And this is a peer-to-peer, the two devices they can connected, they can transmit this one. And more range, more data rate is the Wi-Fi. So this is another protocol. They support the high-speed data. They support the long distances compared to Bluetooth, and they support both 2.4 gigahertz and 5 gigahertz frequency. But these Bluetooth, Wi-Fi, Zigbee is the short range communication. Long range communication, we can go in the other wireless communication protocols such as 4G, 5G. So short range communication protocol, that is good in terms of energy consumption. Long range communication, that is good in terms of the communication distance. But long range, they consume huge energy. Short range, they have the communication limitations. So LoRaWAN comes into the picture. LoRaWAN, they consumes very less power, less than or equals to the Bluetooth. And the communication range is some sort of kilometer, 5 kilometer, 10 kilometers. So that means they cover up the disadvantages of the short range and the long range communication protocol. So right now, various devices, they use the LoRaWAN for such type of application. And we will see in details these protocols next. Now, after that node architecture, if we have decided all the units, we design the PCB, we fabricate all these node on the architectures, and everything is perfectly working. We assume that our node is ready. Now, what next is there? Data aggregation. So nodes generate the data. Of course, the nodes are deployed inside the field of interest. They generate the data, and multiple nodes, they transmit this data to each other. And say, for example, one node, the data comes from the different nodes. Definitely, they need to aggregate this data. So aggregation means the collection and the fusion of the data from multiple nodes to reduce the amount of the data that need to be transferred to the same. So if we can make a Y shape sort of things. So if we make a Y shape sort of thing, there are two nodes are there. One center point is there. If the center point, they connect the data from these two nodes. There are two ways. Either they can directly transmit data one after another. In that case, data transmission is used, and data transmission is used, that definitely they consume huge energy and also not suitable for the low data rate network. So in that case, the other alternative is the data aggregation. We can reduce the size of the data. Various techniques are there, we will see. So reduce size of the data, that means a small size of the data, they consumes less energy as compared to the raw data and one after another data. And also it takes less time to transmit the data to the base station or to the sinks. So for the data aggregation, that means, say for example, if you have the two data A and B, you can take the average of A plus B by 2. This is the only, once again, we comes to the one data, that means 50% we can reduce the data. In that case, save the 50% energy. So here we can say the help to conserve the energy, reduce network traffic. Because the data size is reduced, then network traffic automatically goes down. And it helps to improve the accuracy. That is very interesting. Sometimes we say that, okay, reduce the data means you lose the information. But reduce the data also sometimes they helps to improve the accuracy. Why? Because they reduce the noise. When you transmit the data in a wireless manner, definitely noise comes into the picture. If the noise is 30% noise or 20% noise, say for example, we can say if you transmit the 10 data, then 2 data, 3 data are noisy data like this one. If you transmit the less data, then noise is less. Another reason is that improve the accuracy is that aggregation decision. That means if you have the 3 nodes, and you decide you can transmit only 2 node data. So one sensor, they say the 40-degree temperature, other two say that the 21 and 22-degree temperature, you can select the best 2 sensor data and transmit it. That is the data aggregation. So best 2 data is the data aggregation, then definitely you can improve the accuracy. Why? Because 40-degree sensor, those they observe, maybe possible they are the faulty, maybe possible there are some issues are there. If majority says that the 21, 22 degrees temperature, then 21, 22 is the better. So aggregation not only to reduce the energy, but also helps to make the accuracy. Now, of course, everything positive and negative is there. So aggregation gives a lot of advantages, but has some issues, not disadvantages, but limitation or issues are there. One is introduce the latency or the delay in the network. So can introduce the latency delay. So when you do the aggregation, say for example, you have 3 sensors connected and wait for the data of the 3 sensors, then you can pick the 2 sensory data, which is the best one data. That means wait comes into the picture. Whenever waiting time is there, whenever the aggregation procedure or aggregation algorithms work there, then it takes time. So in that case, we can say the latency comes or delay comes into the picture. Real time, that is whatever the data comes and very fraction of the second you can transmit, not possible. You need to do the aggregation. So latency is there and delay is there. This is an issue. So if your application can tolerate such type of the delay and latency, then you can go to the data aggregation step. And of course, the data loss or corruption is also there because you can take the aggregation. So data loss is also there. So there is a trade-off between the energy consumption, network traffic, and data accuracy. So if you compress the data, definitely you can save the energy, but maybe possible that means latency is increased or not. How much latency increase when you compress the data? What energy saving is there? Whether the energy saving is more aggregation point of view or communication point of view. Say, for example, aggregation takes the X energy consumption and communication take Y. If aggregation take more energy as compared to communication, X is greater than Y, then why we are doing the data aggregation for energy perspective? Your processing takes more energy as compared to communication. In that case, nothing to be used. So definitely there are trade-off. You are not directly use the data aggregation. First, you need to check that how much energy we can save, what network traffic we can reduce, and what accuracy we can achieve if we are doing this thing, and what latency added if my application supports such type of latency or not. So all these points is the part of the data aggregation. These are some standard techniques. There are 3 standard techniques in the data aggregation. One is the statistical aggregation. So whatever the data is from their neighbor sensors, they combine the data from the multiple nodes using some statistical functions, whatever the fixed mathematical functions such as the mean, variation, standard deviation. And you can use the result of the mean as a final aggregated data. So if there are some multiple data, someone says that, okay, I can use the mean, mode, or standard deviation, or the average sort of thing. So take all the data, divide by the number of nodes are there. So these are the mean sort of thing. So whatever the data from the node 1 or it depends on your data types, it depends on your applications, which type of the statistical aggregation is suitable. So most of the cases people use the average. So, okay, whatever the data is comes, take the average and transmit that like this one, because they assume that the environment is same, sensor type is the same. So of course the both data sensor data is also the same. One is the another technique is the spectral aggregation. Here we worried about the location. So grouping node based on their geographical locations. So say for example, a very big campus is there, various departments are there, and nodes are deployed here by the department. So why we are collected all the node data from the different department do the aggregation? Better we can take the aggregation within a one department node, whatever the nodes is there, so that we can measure the that air quality, we can measure the noise level only within the department. So geographical location geofence is also an important. So such type of special data, they worried about the location. So they do all these operations with respect to the location. So in that case, we can say some center of the location, and they can make some radius, and whatever the nodes within that radius, they can take the data and do all these things in that case. So this is the same formula such as you have the n nodes. You can use some function, aggregation function here, and take the decision. So sometimes that what we can do, we can take the average value, or we can take the minimum or the maximum values, like this one aggregation. So noise level. So noise level, why we are collecting all the sensors data 1, 2, 3, 4 in a one building, we need to make the noise level of that building. That means whatever the maximum noise, that is the noise of that building. We are not worried about the low noisy environment. We are worried about the noise of that building. That means whatever the noise inside the building that we need to monitor. And so maximum of the noise is important for us. But say for example, in the winter season, the temperature. So whatever the sensor they that note down the minimum temperature, that is the useful for us. And more than the temperature is nothing to be useful in that case. So minimum and maximum is such type of the approaches they use. This. That so previously we used the location. Now we use the time period. So this is a temporary aggregation. So when you aggregate the data with respect to that time. So say for example, if you want to monitor the vehicles in the daytime. So while we are do the aggregation of the day and night time vehicles, better we can collect the sensory data and do the aggregation only the sensors, though they collect the daytime data, not the night time like this. So time period, if you consider the time period while selecting of the data for the aggregation purpose or do the aggregation with that one, then time period we can monitor. So now it depends on your that application, that whether you want to consider entire 12 hours daytime or you want to consider the 1 hour, 2 hours and other things like this. So we can aggregate the data hourly based, we can aggregate the data, that entire day data like this. But that is there. So these are the three techniques. One is the first technique, that what mathematical function you use for the aggregation. If you are not worried about the location or the time, or reverse, if you can say that you have no information about the location and the time. If you not use any clock, that means you are not able to note down the time. Whatever the data they collect and they store, then transmit the data, you don't know about the timing. Similarly, if they have no such geofence, you are not note down the ID when you deploy the sensors, and there is no location features is there, then you are not able to find out the location. So if you have no option, then definitely you have only one option, is statistical data. In that case, you can, whatever the data is there, without any location, without any time, we can take the mean or these techniques. But if you have the location information and your application also with respect to location, so noise level is the location is effective. Say for example, that agriculture land, and you want to switch on the water pump in one region or water pump in the entire region. So if you, that is a location based, that here the moisture level is very less, that means definitely you need to switch on the water pump so that in that direction some water goes on. So that is the location based, not randomly you can open the for all these regions. So location is the important. Sometimes the time is the important. If you want to monitor the office, then daytime is the much more important as compared to night time. So this time there we can take the aggregation or take the decision based average of the day and night time data. So this is the best on your application, what application is there and what application you are using. Now we come to the third one, basics of the wireless sensor network. One, we already designed the node with all the components we pasted in that. Then we also think about the data aggregation, what algorithm we will use, what techniques we will use for data aggregation, that we also work out. Now we come to the third one, that routing. If I have the information, I aggregate this information, how I can transmit this information to the next node or next to next. So after sensing the data and aggregate the data need to transmit to the base station for further processing. Routing, whatever the algorithms are there, routing techniques are there, determine the most effective and reliable path for the data travel from source to destination. Here there are two keywords. One is the efficient, another one is the reliable. Every time the reliability is not implies the efficiency and vice versa. Say for example, efficient path is in terms of the fault tolerant like this. Efficient in terms of the energy. So this path is very efficient in terms of the energy. They consume very less energy. But some nodes are faulty nodes. Maybe possible they goes down after some time. That means that is not a reliable path. So it's up to you that what is your requirement? Your routing algorithm requirement most efficient. You are not worried about whether the data is transmitted or not. You are ready to tolerate some failure of the data. Then efficiency or an efficiency comes into the picture. But if you are worried about the reliability, that means your data must be transmitted, then definitely you are worried about the reliability. Even they consume more energy, it takes more time, but you are worried. So it depends on your application, whether you are going in this direction or that direction, or use the fuzzy logic between lambda efficiency plus 1 minus lambda reliability and lambda varying from 0 to 1, like this one. So it depends on your application, what application you are using. But the routing refer to the process of forwarding the data from source to the sink node using intermediate node SDP. Here we use not directly one hop, that means multi-hop communication is there. So some intermediate nodes are also there. So this is the responsibility of the routing. They also take care of the intermediate nodes. That means intermediate nodes have the both responsibility, collect the data and transmit the data. That means their framework, they support the routing protocol in the both aspect. And application or the advantage of the routing is helps to improve the accuracy, because you transmit the more data to the sink, then definitely you find out a more accuracy, and timely you can find out efficiency of the sensor not collect and processing of the data. So these are some advantages that they help to the wireless sensor network when we use the routing. So select the routing which is suitable in that categories. Now, objectives of the routing in the wireless sensor network. When you do the routing, what objectives keep you in mind? every time the energy comes into the picture in wireless sensor network. So whenever you select the routing protocols, whenever you select the routing technique, you must be worried about the energy consumption. Select the routing protocol which consumes the less energy, so that your network can survive more and more. So routing protocols should minimize the energy consumption by reducing the number of transmission and receiver as well as the distance between the nodes. So they can select the shortest path like this one, so that the energy consumption goes down. There are two paths are there. One is the A to B, B to C. Other one is the A to D, D to E, E to C. So there are the 3 hub count. Here we have the only 2 hub counts. So 2 hub count is better than 3 in terms of the energy consumption. So definitely this is the responsibility of the routing. They find out the shortest path so that we can reduce the energy and the time. Another energy efficient routing protocol, they also worried about the packet format or the header size and other things. So if you use some heavy header size or use some bulk information as a control information, definitely that is not suitable in terms of the energy consumption. Now, reliability is also the another part of the routing protocol. That means usually wireless sensor network we deploy in the forest fire monitoring, some sort of thing that or disaster monitoring. So these are the hazards environment and may have the limited connectivity. That means if your routing is not working perfectly, you are not able to do anything. So routing protocols should ensure the reliable delivery of data even in the presence of the network failure. So if one network goes down, then routing protocol is much more capable. They can find out the second best path. Of course, the first best path is already there, they tear down because of some failure is there. Then they can go in the second best path. So most of the case, these routing protocols or the relay node, intermediate node, they can save the 2 or 3 path. One is the best path, second best, third best. If one node goes down in the first best path, they can go in the second one and they call the second one. Scalability is the another important point because wireless sensor network is a large number of wireless sensor network in the network. So definitely scalability comes into the picture. You deploy the large, so your routing protocol supports the thousands or even millions of the nodes simultaneously. That means the header size is increased whenever you transmit the data from A to B, B to C. They can every time they can add the values like this one or whatever you use the some constant is there, that is every time they increase +1 in the hub count. So whatever the size of the +1 integer, that is so long so that you can support up to the thousands of the node. And low overhead, that means whatever your additional overhead in the network, that is the low control packets information. So if you use huge control information, then definitely that is not suitable for wireless sensor network node because of the processing and memory resource transfer. Of course, the load balancing is also an important part. So every time, don't assume that you select a one path and transmit all the data in a given path. If the load is high, routing protocol responsibility is to diverse the load from one part to the another part to avoid the congestion and the distribution traffic, everything like this. Otherwise, congestion comes into the picture and bottleneck comes into the picture, and this is not working perfectly. Now, based on the algorithm, based on the technique, routing protocols can be classified into various classes. So one is the flat routing protocol, which is the simplest routing protocol. That means distributed routing protocol where all nodes have the same responsibility and communicate directly with the sync. Whatever data is there, I can take the data, I can directly communicate the sync. This is the flat routing protocol, but practically that is not much useful. Why? Because of the direct communication. Hierarchical routing protocols, they support some tree structure sort of thing that or the levels. Divide the network into the multiple levels. This is the level 1. Level 1 devices connected to the level 2. Level 2 only devices can connect it to the level 3. All level 1, but that level 1 devices cannot directly connect it with the level 3. So in this case, the level 2 devices are always the high energy nodes, such as the cluster head sort of thing. So cluster head can communicate to the sync node and other nodes can communicate or connected with the cluster head nodes like this. So here we can call it the hierarchical routing protocol because they have some hierarchy that low energy node, high energy node like this one. Third one is the location based routing protocol. So they have the location information and they use this location information for selection of the path. Here they are not worried about the location. They worried about the node type, that whether this is the suitable for the cluster head or not. Here we are worried about the location, that when you find the routing path, when you run your algorithm, you are worried about the location. This let me this node is so far, so why I am forwarding my data to that one? I can go in that way. So this is the location based information. And another class is the data-centric routing path. That means whatever the data, who else is responsible, who is the take care of the data, where the data is collected, like this one. If you worried about that, if your algorithm is take care of these things, then you can need to go to the data-centric routing path. Another is the power. That means if you want to reduce the energy consumption, that means you need to focus only on power-aware routing algorithms. That means you select the path, they have the sufficient energy, they consume less energy, like this one. In that case, we are not worried about hierarchy, whether the hierarchy is maintained or not, location is there or not. We worried only about the energy consumption. Sometimes the energy consumption is not only the quality of service, your quality of services such as the delay, throughput, and your packet loss and all other things. So if you are worried about that type of the quality of services, you need to consider the QoS-based routing protocols. So here we are not worried only about the power consumption, we also worried about the other type of the quality of services. Now, these are the classification of the routing protocol, how we can classify the routing protocols. Another classification of the routing protocol is based on the storage based on the demand sort of thing. So say for there are two classes. One is the on-demand routing protocol, other one is the table-driven routing protocol. This is another class of classification. And on-demand routing protocol establish routing path only when they are needed. Okay, there is no routing path initially. You are completely free of mind, has no information about the route. But when the node need to transmit the data, they create a path. They create a route sort of thing from source to the destination. So in that category, we can say when the demand comes into the picture. So when a node need to send the data to the destination, it initializes a route discovery process to find a path to the destination. And of course, they make a path and transmit their data. AODV is the well-known routing protocol in that case, a wireless sensor network and a rope network. And of course, the another is the DSR, dynamic source routing protocol. So these two routing protocols, they are the on-demand routing protocol. And when you require to transmit the data, you can transmit the data. Another is the table-driven routing protocol. That means in that case, routing protocols maintain the routing tables in all the nodes in the network. That means each node, they have the information about the other nodes. You have the routing information. Whenever you have the data, you can start transmission of the data. You are not worried about to collect the information of the network, make the routing path, and then you can transmit. So delay is very less. You already have the information in table driven. So table is already there. Table has the information about the node, about the maintain the routes and how we can make the routes and all other things. DSDV is the well-known routing protocol, is the table-driven routing protocol. So these two routing protocols, they have their own advantage, disadvantages, such as the on-demand routing protocol. And the memory point of view, that is good because you are not required to save any information. If the network is so dynamic, that means nodes comes into the picture very frequently, they can change their location, then AODV is the good one option. Why? Because otherwise, every time you need to update the tables. Here, there is no table why we are required to update. Whenever we need to transmit the information, we can collect the network information, make the routing path and transmit it. So in that case, we can say we are not worried about making the path, already save the information and do all these things. So on-demand routing protocol is suitable in terms of the space complexity for saving every time the information, and in terms of the dynamicness, if network is so dynamic, nodes have some mobility, then this is good. But if you want to transmit the information as soon as possible, whenever the information generated, even you have not able to wait the time till the routing path discovery and other things, then table-driven routing protocol is good. You have always the updated information. Whenever you have the data, you can take the routing protocol to transmit the data, and you can successfully transmit the data in that categories. We can see some little bit information about the AODV, DSDV, and DSR routing protocol. So AODV routing protocol, as we already seen that this is the on-demand routing protocol, meaning that routes are only established when need, rather than maintain the constant routing tables. That means you can make the routing path. Earlier, there is no information for that one. Another feature of this is their name suggests the distance vector routing protocol. That means they work with respect to the distance. So if I have the two paths, I can select a path which has the least distance and less distance as compared to the other one path. So this is the distance vector based, and in terms of the communication, we can say hop count. So node A transmit to node B transmit to node C. That means in that case, we can say this is the two hop count. So AODV routing protocol select a path which has the less hop count. So this is the distance vector. And how they can make the path? They use these type of packets and the messages. So here, very first root discovery comes into the picture. When a node need to send the data to another node for which it does not have a root, it initializes a root discovery process which flood the network with the root request packets or root request messages. So whenever you have the information, you flood the root request message. Whatever the neighbors are there, they receive your root request message. Okay. And whenever a node receives the root request message for a destination for which it knows a route, it sends the route reply message back to the source node. If they have the destination information, otherwise, what they will do, they forward this route request message to the another node. If I have the destination information, I have the sync information, what I will do? I will reply back as a route reply back message to the source node. So with the help of these route request message and route reply message, the AODB can make the routing path. And this is the hop by hop routing protocol. As we already see that this is a distance vector based. That means each node forward a packet to the next node along with the path to the destination. So if I have the information, the path A to B, B to C, C to D with the help of these two messages, and when we transmit this data, I have the that means the path information, hop by hop information, that how we can transmit this data from this one to the next location. AODB routing protocols use the sequence number which prevent the routing loop. So what is the looping problem? That means, say for example, A send to B, B send to C, C also again send to the B, B to D, like this one. That means the packet is moving inside the loop, not source to the destination like this one. So how we can prevent this one? We use the sequence number. If the sequence number is same as the early one, that means the sender understand that, okay, this is my own packet that I forwarded to the neighbors, never forward to the neighbor. And once again, this packet comes that neighbors to me. So with the help of sequence number, I can avoid that one packets or the information so that we can break the loop sort of things. Route maintenance is also there. They have the messages for route maintenance, and they periodically they broadcast such type of the route maintenance packet so that they can understand that whether the path is still exists, whether the route is still there or not. And AODB routing protocol not only have the one option, they have the multiple supporting options. So for example, if they find out the three paths, one path is the shortest, second one has the not as good as one, but that is also a good one, and third one is the only the path that is there. So we have the three paths in that case. So AODB routing protocol calls the first one path, which is the shortest path in the network in terms of the distance. If the path has some problem, then AODB routing protocol calls the second path. That means multiple route support is there. So that you are not required to every time you can go and select the second path, make the path and other things. You have the option to transmit this one. And this routing protocol is suitable for the small to the medium size. That means this is suitable for the medium size, not only for the smaller, because you are not worried about to update the information. Whenever you want to send the information, you can create a path. That means you can maintain a big size topology networks in that case. And because of this beauty, and this is a very well-known protocol, they have the standardized, that means IETF, they give the standardized of this AODB routing protocol. And right now, various devices and simulation, they have the AODB routing protocol. Now we go to the another on-demand routing protocol. This is also a reactive routing protocol, which is the DSR routing protocol. So dynamic source routing protocol, this is also same as the previous one, on-demand routing protocol. That means whenever you require, you can make the path. And this is the source routing protocol where entire route is including in the packet header by the sender node. So whatever the route you have traced, you need to make the entire route information inside the packet header. You are not able to select, that means, okay, I can put the information only last two hubs. You need to make the entire route information because this is a source routing information. When a node wants to send a packet, it broadcasts the route request, similar as previous one, to their neighbors, which forward by the other nodes until they reach to the destination. And if that's a fresh route destination, then they put in the cache memory and reverse back to inform to that, yes, there is a one path is there. So everything is same as the previous one, only that is they have the entire route information starting from the source. Similar as the AODB, they also support the multi-path routing protocol. That means they have multiple options are there so that they can save their routing information. And yes, there are some challenges in that in the DSR routing protocol is the flooding attack. That means when you find out the path, you broadcast this information or flood this information to the entire network or entire nodes like this one. So that means maybe possible you are a correct node, but maybe possible some are the malicious node, they also do the same thing. So unnecessary root request messages comes into the picture and they disturb or interrupt to the communication protocol in this. And similarly, this is also good for the small and medium size because you are not required to save the entire information. And whenever you require the information, you can create the path. So good for the military communication, disaster, and environmental cases. Third one is the DSDP routing protocol, and this is the first one is the priority routing protocol. That means in that case, you have the table information, entire information saved inside the table, entire network topology information saved inside the table. And this is based on all pair shortest path Bellman-Ford algorithm in data structure, if you've gone through. So make the matrix, find out the shortest path working accordingly. Okay, so each node maintains a routing table that contains the information about the next hop to reach a particular destination. And of course, they need to periodically update this information so that every time they have the updated routing table. And they also use the sequential number of each route. So differentiate between the old and new route request. So maybe possible this route request is the older one that is inside the loop. You receive once again the same information. So to avoid such type of constraint that they use the sequence number to avoid the routing protocol. And this is the distance vector, similar as previous one, to calculate the distance and direction to the destination. So that is also similar as the hop count. That means 2 hop count, 4 hop count. Which one path is better? 2 is the better as compared to 4 hop count. Take this one. But they support the small network, not the large network or the medium network. Previous one, they both support the medium network and the small, of course. Here they support only the small network. Why? Because of the table required. So if your network is so large, your table size is very big. Whenever a node changes their position or whenever a node goes outside because of the low mobility, you need to update your routing path like this one. And another is the count to infinite problem is there. So that means that advertise a new route within the known matrix to the destination node. Always use the longer route like this one. So they always rotating in the loop and advertising. So count to infinite problem comes into the picture. And this definitely they need to take care of all these things. So these are the 3 protocols they use for the data transmission. And we can easily classify into 2 categories. One is the on-demand, other one is the travel demand. Now these are the routing protocol in the network. So node designing, data aggregation, and routing. Now we comes to the communication protocols. So how we can communicate this data? Routing protocol is some sort of the algorithm. You can make the path. But for communication purpose, the communication unit is there. They use some communication protocol, and we can use this communication protocol on that path like this. So up to now, any question or doubt, any query is there? Okay, so now we sorry. Yes, now we continue communication protocol. So wireless sensor network, they support various communication protocol, as we already seen that. And very well known is the IEEE 802.15.4 standard. So this is not only the communication protocol, this is the standard, and the communication protocol is based on that standard. And this standard is designed for the low rate wireless personal area network. That means you need to transmit a very limited data, and your personal area network is there. You can transmit your data in that case, and it works on the unlicensed industry, scientific, and medical bands, ISM band. So this is the good that you are not required to pay any cost while you use this one protocol or while you use this standard for transmission of the data. So this standard, they specify the bottom 2 layers, that physical layer and the MAC layer. Upper layer is depend on your routing protocol or depend on your protocols, whatever communication protocol, but bottom 2 layers is definitely specify the physical and MAC layer based on the 802.15.4. And these 2 layers, the physical layer and MAC layer, is of course the low power, low cost, low data rate supporting wireless communication. And good for wireless sensor network, industrial automatic, smart grid, healthcare, and other things. And beside basic of the other routing protocols such as ZigBee, 6LoWPAN, wireless, ACR, all these protocols are based on that one 802.14. So here, this standard, they use 2.4 gigahertz frequency and 915 megahertz, and this one. And they use the 250 kbps data rate. So this is the important point, very low data rate is there. Don't assume that you can transmit the video sort of things. This is suitable for data transmission, a small size of the data. They support the DS3 and FSK modulation technique for modulate and transmission of the data. At the receiver side, once again, they demodulate and they can collect their data like this one. And this is a beacon-based, beacon-enabled network. That means they support the beacon-enabled and non-beacon-enabled. Both type of, they have the support 15.4. Beacon-enabled network where periodically beacon frames to synchronize the devices and transmission of the data. That means periodically you can ping the data, whether you are alive or not, whether you want or not, but that means you receive a data in a fixed period of that time. Non-beacon based, which is some sort of thing, the CSMA versus CD. Okay, multiple access and collision avoidance techniques are there and they can get whenever the slot is available, not every time or periodically beacon sort of thing. So 802 point, they have the what type of facilities, it's up to you that what type of applications is there. And data rate is also 250 kbps is sufficient for transmission of the data. And the frequency band is the license free or free spectrum frequency band. You can use that one. And this spectrum is specially designed for industry, scientific and medical purpose. Now ZigBee protocol. So when we talk about the ZigBee protocol, that is based on the 802.15.4 standards. That means whatever the properties and the qualities of this standard 15.4 standard that is already incorporated with the ZigBee protocol. That means they also consumes the low energy, low power consumption, low latency, and that means they also high reliable and the security. Why? Because that is the 802.15.4 based on that one. So they automatically capture all these things and properties are there. And they also support the flexible network architecture, allow to deployment and management of the wireless sensor network. And they support the 2.4 gigahertz because of that 15.4 properties. Application is whatever the industry application that we have seen, the healthcare applications is also there, building automation. This is a very interesting picture. Now, OSI model is you already familiar that OSI model in the computer network, they have the 7 layers: physical layer, data link layer, network, transport, session presentation, and application layer. This is the ZigBee or 15.4 like this one. So bottom 2 layers that we already said that this is the 802.15.4. Then after the network layer is there, then they merge all these 2 layers, that presentation session layer, they can say the application interference in the ZigBee, and application layer is there already. Transport layer is some sort of security. So in that case, the changes in the OSI model and the ZigBee is at that level. These are the already you fix because of you use the 15.4. So you have no control in this. And here, this ZigBee, they merge all these protocols together and make this type of architecture: layer 1, layer 2, layer 3, layer 4, layer 5, and layer 6. And these layers, 5 layers, that means because these are dotted, that means not clearly there are 2 layers. That is, they have the different properties, but that is only in a one packet sort of thing. So one bigger layer like this one, second layer, third layer, fourth, and fifth layer. 5 layers we can convert OSI model in the ZigBee communication protocol. Now the second one is the Bluetooth communication. Of course, Bluetooth that covers in our smartphone, and numbers of devices they use the Bluetooth. Why? Because they consume less energy, and they have the short range communication. You can communicate some meters sort of thing. Bluetooth developed in '94 with the Ericsson company, and now it's widely used because of their low energy consumption and short range communication. And Bluetooth devices must be paired with each other before transmission. That is a very big thing. That means we can say good or bad, because positive point is that when you pairing, you can share the security and other things. So security and other things you can maintain. But the challenges is that pairing is required. That means that is a time consuming, and you are not able to connect the large number of devices, because one-to-one pairing is there. So the some constraint is there. You can connect up to the 3 devices, or you can communicate only up to the, or connection up to the 8 devices. So if you want to go communication more than that one, then definitely you can break some communication links of the others in that case. So this is the cause of this one in that case. And they also perform the better performance, security, power efficiency, and other things in the Bluetooth case. But the challenge is the limited range. Communication range is very short. Their bandwidth is also a one constant. You cannot transmit a huge size of the data, and interference from the other devices comes into the picture like this. And now the Bluetooth, similar as the previous one, Bluetooth also have the application layer and Bluetooth stack layer. And this is the, that means radio layer, this is the make layer sort of thing, and basement layer, physical layer like this one. So application layer is responsible to connect the Bluetooth with their application, whatever the applications are running. So it works as a sandwich between your application, whatever the Android application is there in a smartphone, and your Bluetooth device. So intermediary application layer responsibility is there. Complete Bluetooth properties, whatever the Bluetooth architecture or Bluetooth is there, they work in the Bluetooth stack layer. They have the capsules, or we can say they have the functions of the SCM, host control. They control the devices. They maintain the link management protocol for maintaining or connection the link establishment, logical link control and adaptation. L2 cap is there and DSP is there. So these four part of those four sub layers, they are completely worried about how to connect, how to manage, how to transmit the data and all other things. Now, make layer, that is responsible, radio layers, that is responsible for frequency hopping spectrum, how to change the format of the data and transmit the data from physical layer to the upper layer. And last one is, of course, that is the modulation technique, error control, error condition, and control this. So this is the pictorial diagram of the Bluetooth layer, that is the physical layer, data link layer. And this is what we are talking about, that they support the gap, they support the ATT, L2 cap is there. So all these are worried about how to control the host, how to make the connection and other things. And this bottom application layer, that is work intermediator between this and your application. So this is all about the Bluetooth. Now we can see that we already seen that this is working the parallel, and these two protocols, they are worried about the connections and other thing. So here physical layer is 2.4 gigahertz ISM band they support. Then data link layer, in terms of data link layer, Bluetooth use the link management layer and L2 cap and other things, that layers. And whatever the presentation session transport network layer, that is they are using in terms of these layers, whatever the protocol sub layers are there, SCL, SMP, L2 cap and SSD. And they also use the TCP and other thing for transmission of their application. So this type of architecture is the Bluetooth architecture or the model. And this is the OSI model compared with the OSI model in this one. Wireless, here is the another protocol, which is also based on the 802.15.4. And the beauty of this one is also that is very lightweight and reliable, and that means the protocol that is secure because they use the encryption and other things. So wireless communication protocol based on highway addressing remote transition here communication protocol. So they use for wireless, they use the wireless. Otherwise, they also support the other type of the communication medium. And bottom two layers is the 15.4. That means whatever the modulation technique and other things are there, whatever the gigahertz frequency band is there, that is also there. Here they support the mesh topology as compared to peer-to-peer topology in the Bluetooth. So this is the then beauty of this wireless air protocol. They support the mesh topology. That means the numbers of devices they can connect with each other with using the mesh topology. And because of the mesh topology, that is also suitable for the harass industrial environment where the high level of the influence of obstacles or failure is there, so that at least one node can communicate to all nodes, or at least one node can communicate to other can communicate to other, so that finally you can find out the entire information because of the mesh topology. If one node is only connected with another one node peer-to-peer, then maybe possible some obstacle, some there's harass environment, some failure is there, you are not able to find out the information. So this is the beauty of this protocol. That means they support the mesh topology so that at least you have the information. And as we already seen that they support the encryption and authentication in so that this is a secure and reliable communication protocol. Similar as the Bluetooth and other that we have seen the protocol, they also have the 5-layer protocol architecture. Application layer working in between your application and the bottom layer. So this wireless layer, they design whatever that means requirement is there. Say for example, they need the application layer, they design their device descriptive language, DD language, so that they can implement their application layer. For the network layer, they provide the network functionality for connections and other things, wireless network management protocol, NMP, they design only especially for the network company because they need a configuration and management both together. So that means they design their own protocol for communication purpose at the network layer. Now, transportation layer for end-to-end communication for between the devices, they design the wireless air transport protocol, WTP. And because of their design, there are different protocol for each and every layer. They have the good control on that one. That means they can control the security, they can control the privacy and for handshaking and other things. So they say the security and reliability both together, authentication and encryption is there. Because they have their own protocol each and every layer. Data link layer, they have the wireless data link layer protocols for error detection, for error correctness, packet routing and addressing. So it is very popular and powerful protocol, especially for wireless sensor networks. And the physical layer that is wireless physical layers is there. This is the architecture of this one as compared to that ZigBee and other protocols. So ZigBee, they work in these 2 layers, the rest of the ZigBee. This is the OSI model. We can see the layer 1, 2, 3, 4, 5 layers is there. So this is the physical layer. This is the for the data link layer or the MAC layer. Since this is also somewhere this one, so they also use the 2.4 gigahertz transmission. Then they use the secure reliability comes into the picture, power optimization at the network layer, and auto segmentations and other things at the this one network layer and upper layer. So this is about the wireless communication protocol is wireless. Now we come to the Wi-Fi. Wi-Fi takes more energy as compared to these protocols, but they have a long communication range as compared to that one previous earlier protocols. So IEEE 802.11 you say, or you say refer as a Wi-Fi, both are the same. So standard basically they change that 802. They use some A, B, G, N, A, C, and A, F based on some their properties, based on some changes is there. So it is good we can use the 802.11 as in place of the Wi-Fi like this one. So while so that you can easily distinguish between this and that one. Otherwise, it is very tough to distinguish. And this is also a standard for WLAN, and it is created by the IEEE. And this work on the 2.4 gigahertz, 5 gigahertz, even 16 gigahertz frequency bands also there. And what is the difference between these A, B, G, and 802.11? With the different specifications such as the data rate, which one is the high data rate, which one is the low data rate. Frequency band, which frequency band they use the 2.4 or 5 gigahertz, they can change with the help of ABGH. Channel width, whatever the channel bandwidth is there, modulation techniques and other features. So A is use the different frequency band, B use the different frequency band, like this one. That means if you use the different data rate, different frequency band, you can use the different A, B, G, and AC. So this is the 802.11 protocol stack that this is similar as the OSI model. They also have 1, 2, 3, 4, 5 layers. Layer 5 to 7 is merged in the application layer. That means they are completely control on upper 3 layers. Rest of the things are the same. Data link layer is 802.11. Their physical layer that is ABGS is depend on your perimeter, but yes, that is a different as compared to previous one. Then data link layer, they have all their MAC layers, and now upper layer is the IP TCP layer is the same as OSI model, and other 3 layers merged together. So here we can see that the main difference is the this one. So they divide MAC layer in that means the second layer data layer into 2 sub layers, the MAC layer and the logical link control layer, so that they can make the connections and do all other local connections and responsibility. IP and TCP transport protocol is same as our OSI model in this that Wi-Fi. And application layer, they support that means HTTP, FTP, SMTP, all these they are supporting perfectly in the 802.11 and Wi-Fi. Now we come to the LoRaWAN. This is the last one, long range communication protocol. And that covers the advantage of both. That means they consume a very less energy and they have a huge long distance. That means they can communicate up to some kilometers sort of things, not only 1 meter. And the lifetime is some years, 1 year, 2 years lifetime. But yes, they have the negative point is the data rate. Their very limited data rate is there. So you can transmit the sensor data. You are not able to transmit some video, audio sort of things. Security point of view, this is the end-to-end encryption. So there are 2 types of the key in LoRaWAN. One is the application level, other one is the network layer. So network server, they share their key, application server, they share their key. So this is a completely encrypted and secure data transmission. We are not worried about this. Since that is scalable, large distance communication is possible. That means they support the thousands of the devices and they also communicate a huge distance. So scalability is also not a problem. And this is the open standard. That means it is not controlled by any company. You can change, you can modify, the protocol, whatever based on your company. It supports star of star topology that all devices are connected with the gateway. transmit. That means they also support the one-hop communication. All devices can directly communicate with the gateway. And they support the two-way communication. Device can communicate to the gateway. Gateway can also communicate to the device. Not only one-way communication. Geolocation, that means if you take some information, then they also support like geolocation. That means at which device, where is their location, and what they are. And it is a cost effective. Why? Because we are not required the relay devices. You can directly communicate to the gateway. It's a 10-kilometer distance is more than sufficient to direct communication inside the campus like this one. So this is a smart home. They deploy some sensors and they have the LoRa devices. They can directly communicate with the LoRa gateway. So here the LoRaWAN protocol in between this. After that, we use the normal protocol, whatever the protocol is there, then not the LoRa protocol. LoRa protocol work in between, the nodes can communicate with this one. This is another pictorial diagram of the LoRaWAN. The nodes, they can communicate with the gateway, gateway communicate with the network server do something and show the result to the end. So this is the application of the LoRaWAN. This is another application of the LoRaWAN in intelligent transportation system. Some vehicles are there. So they can detect, of course, if someone is moving perfectly or not, they are doing something wrong or not. This is the agriculture application that where a cattle is enter inside the agriculture field. Then LoRa node can detect, they can transmit to the gateway, gateway can detect this information and generate the alert to the end user. These are some examples. So IIT BHU Varanasi campus is right now the LoRa enabled. We set up our own LoRa gateway and LoRa network inside the campus. And this gateway is connected the chirp server initially. So you can see that this is the location. They show that, okay, this is. So here, this is the thing network server. They show the location. This black color dot indicate the gateway. So in India, this is the LoRa gateway at IIT BHU Varanasi we set up. So you can see that most of the European countries, they use the LoRaWAN right now. They have their own gateway, they can communicate, they can use perfectly. So outside the India, that in the European country, they use the LoRaWAN perfectly to transmit the data to this, all these things. This red color indicate the region of the LoRaWAN in IIT BHU. We tested that, yes, it's working perfectly. This is the outdoor gateway shape that put on the roof of the Department of CSE. And this is the how we can check the region that whether it is covered or not. We need to, how we can make this ring sort of thing. So if we cover some selected point, then we can draw this line that, okay, this line is covered. That is whatever the point inside this region that is covered by this LoRaWAN, whatever the LoRaWAN we have deployed. So you need to check manually and go and check these points. Then after you can make a region that, okay, this region is covered by the LoRaWAN. So all these buildings that we have checked that we have covered in this LoRaWAN network. So LoRaWAN is recently that find out a huge popularity in terms of the application, in terms of the energy, in terms of the cost. Finally, becomes one that means a different subsection that section. So numbers of network simulation is exist for wireless sensor network, and these simulations helps to provide a real-time scenario. You can modify the protocol. You can work in a different protocols with a different aspect like this one. NS2, NS3 is very popular. OPNet, NetSim, and AccuSnet, and numbers of other. These are some examples. So if you want to work on one networking protocol or wireless sensor network protocol, if you want to modify, first you need to work in these simulators so that you can familiar with all the protocol stack or whatever the header files is there. Then after start work on the node so that we can familiar with the platform and then we can jump on this one. So this is the last one that if I want to start the wireless sensor network programming, I'm not familiar with the simulator, neither the node, how we can do. So if you are familiar with the Python, you can make some small program first, and then after you can jump to the network simulator and finally go to the node design. So here I have written one program in the Python for the node design. So one design one class node, and class node, they have the node ID and they generate some information between 0 to 20, whatever the information is there. If I read myself, read the value, then I'm reading the value. If I, that means send this or forward this information to other, I can call the send value. If I receive the information from other source, then I can call this function receive. Now I created 5, 0, 1, 2, 3, 4, 5 nodes in the network here. And while true, jab tak network exists, whenever the network exists, you can transmit, you can receive the information. You can go each and every nodes, whatever the nodes you have defined, node IDs are there. Make some speed slow so that we can add some sleep time in this and read the values, whatever the value randomly you have generated. And if I'm not the destination, I can forward this information to the other. Here I am not decide the destination. So this, if you run this program on Google Colapse, then or the Python, anyone Python, then they can continuously working because I'm not able to find out the destination. So one node receive a value 20 from node 0, node 2 also receive, node 3 also receive, then node 2 receive the value 4 from node 1. So each node they can transmit the values to each other. So this is a one toy example that how we can create the node, how we can transmit the value, how we can receive the value in wireless sensor network, and how we can write the program in Python programming for this. So this is all about from my side. Thank you very much for this. Now, yes, please.
Yeah, thank you, sir, for insight in the basics of wireless sensor networks. I would request the center coordinators to collect the queries of the candidates, or they can directly ask the students to, come to the mic and ask the question directly. So meanwhile, there are a few questions in the chat box. We can address them.
Yes. Okay.
Just few questions for my side. Is IST Indro.
Yeah, sure.
Yes.
Yes. Hello, good afternoon, sir. Very nice blessing of your on wireless sensor technology to us, sir. Really fantastic session. Learned too much thing, but few question I would like to ask if you will permit me, sir.
Yeah, sure, definitely. Yeah, please.
Sir, we heard about or learned about all the things. So what about the Wi-Fi, sir? What about the Wi-Fi in enabling technology? I am asking, such as Wi-Fi, Bluetooth, ZigBee. You taught in a fantastic manner. So what about the Wi-Fi? Where to use it?
Wi-Fi used in, say, for example, a smart city where the numbers of vehicles are there, they are moving, some denser environment is there. And this is some sort of, that means we can say, deterministic manner deployment. Wi-Fi is suitable in that environment. Say, for example, forest fire monitoring, you are not able to use the Wi-Fi because you don't know about where is my node and what we can communication and other things. That is not suitable in that environment. Wi-Fi is suitable in the smart cities where various nodes are there, there and what they are transmission. So in that case, we can use the Wi-Fi. And this is, yes, this is a little bit new. Right now, it comes into the picture. Yes.
Thank you so much. Sir, one more question, if you will permit, sir.
Yeah, please.
Sir, as you said, the light detector principle. So is it LDR you are talking about, light dependent register in the cadmium sulfide or something else?
See, that what we have discussed in this, that is some sort of classification technique. Now, what material you are using, that is some sort of different. So what classification we have done, classification based on their principle.
Oh,
okay. So,
resistive, capacitive, inductive principle that we can say?
Yes. That is.
Sir, one more question, sir. In fertilizer, for testing the fertilizers, are there any sensors? Because I am a farmer myself. Firstly, I am saying farmer, and then I am saying assistant professor. So, for testing the fertilizer, are there any sensors, or how we can use?
Yes, soil quality measurement sensors is already there.
No, sir, don't want to measure the soil or the moisture or humidity. I want to test this, suppose urea, potash, all that things.
No, I'm not aware about that. Maybe, yeah, definitely the sensors are there because people can check the quality of that fertilizer. So sensors are there, but I'm not know the name and that categories.
Right,
yeah,
right.
But lab test is there. That means the sensors are already there so that they can measure the quality of the fertilizers when they receive the packets and other things. So that is there. Yes, yeah.
Right, sir. Thank you so much, sir. The last question, sir, as in our Indore or in most of the Mahanagar launched the 5G technology. So by keeping in mind all the technology, are there any changes will we want to do in various protocols that we have learned recently?
See, the first point is that one, the wireless sensor network, we are not talking about 4G or 5G because it consumes huge energy. So 5G is the completely different type of, that means this is not suitable for wireless sensor network.
Okay.
And my suggestion is that right now that LoRaWAN, because recently also, that is a very burning topic and numbers of applications that we figure out. Say, for example, Kumbh Fest or crowd monitoring, huge crowd is there, and one baby missing is there, some sort of thing. You can create baby child, wristwatch, some sort of thing, Lorabin. So number of applications are there.
Qualcomm, sir.
Sorry?
Qualcomm is one of the platform where nanny-tual baby taking care.
Numbers of platforms are there for you can make or use the LoRaWAN. So this is one of the example that you can make some baby watch.
Verify or Intel Edition. Can we use all that in the same fashion?
Sorry, can you please repeat your question?
Yes, sir. Please. Sorry for that. Sir, such as the Arduino platform, there are various variants, Raspberry platform or BeagleBoard or Intel Edition. So in the same manner that you showed to us, can we go for all the things?
Yes, definitely you can go for all that. That is all these are the protocols. Platform, you can select any one of these things. So
all these protocols are linked to the physical data link and up to network layer, na sir?
Yes, up to network layer. Up to application layer, that is they have there. Not only the network layer, but up to the application layer. That means they can transmit the data up to the end user, sort of thing.
Right, sir. Nice talk, sir. Understood all the things in a well manner. And thank you so much for answering the question.
Yeah.
Good evening, sir. Sir, I am Drashti Jain from MCA student in DAVV College. Sir, I have the question that we have learned about the protocols, data protocols that are COAP, MQTT, and some of the protocols DTS and SDP. Where do we use them in the wireless sensing network?
Yes, so that is a very interesting question. So see that wireless sensor network and IoT, they are two. That is, as we already seen in the PPTs, that wireless sensor network is the subdomain of the IoT. What protocol you are saying, MQTT and COAP, these are the IoT protocols, not the wireless sensor network protocols. So say for example, MQTT, they have the broker, they have some consumer or some subscriber is there. So these protocol, whatever the names you suggest, that is the IoT protocols, not the wireless sensor network protocols. Yes.
Thank you. Greetings, sir. I am Anushka Saxena from Develya Vishwavidyalaya, Indore. First of all, thanks a lot for the insightful session. I got to learn a lot of new things today. So my question is that I saw a comparison between the OSI model and the communication protocols of WSN. So, sir, I want to ask that as OSI acts as a reference model to form a basis of the further protocols. So, do we have a similar reference model in WSN as well?
See, OSI model is a theoretical model, conceptual model. That means again, if you open your system, you are not able to find out any OSI model in that. So OSI model is a conceptual model. WSN model, TCP IP model, these are the logical model. That means whatever the protocol is there, you can make in there. So WSN, they have 5-layer models. OSI is the 7-layer. Maximum level is the 7 layers. Now these models, either we can go to the ZigBee or we can go to the LoRa, whatever is there. So we pick some layers, we can merge some layers of the OSI model so that we can make the models for these protocols. Okay. So base, you can take the OSI model. OSI model, they have the very clearly distinguish the protocols and the layers. Now, if you want to go to the ZigBee, you can merge these 2 layers and make as a 1 layer, like this one type of the combination is possible. So most of these either IoT or wireless sensor network protocols, they support the 5-layer models. They merge these upper 2 layers, upper 3 layers, because they have very limited features. Why we are required as separate layers? Normal networking, they need a huge level of the encryption, decryption, or changes in the format or compression, decompression. Numbers of things are there. So that OSI created 7-layer models. You can put each and everything separately so that you have the good control. But wireless sensor network or ad hoc network, mainnet network, they have a specific application, have the specific very low data rate and other things, so that we are not putting all together. In that case, we can merge some layers so that we can reduce some functionality and very limited functionalities there. So for the learning purpose, very first, we need to go to the OSI model, understand the entire OSI model. Peterson book networking is the best one for that. So Peterson book networking, they explain a very good numeric examples and other thing. Then we need to shift to the other IoT protocols or the wireless sensor network protocol. If someone is not understand OSI model, it is very tough to understand the others models. I think so. You got the answer.
Yes, sir, definitely. Thank you so much.
Yeah.
Yeah, any other questions?
Bolo, please hurry up.
I am Seema Joshi. So my question is that we are discussed about routing protocols. Then what is the QoS based routing protocols and where it is used?
So see that we have seen the AODV routing protocol or DS. So they work on the hop count, distance based. So if you use the 2 hop count, other path is the 1 hop count, we can select the 1 hop counts in place of the 2 hop count distance. So A node is the source and someone S is the destination, 1 hop count, that means direct connection, or 2 hop count wire to wire, that is there. So in that case, we can say your quality of service is the hop count or the distance. Now someone want to work on energy efficient routing protocol in terms of the energy. So maybe possible you can take the 2 hop count that takes less energy as compared to the 1 hop. Okay, so other ones say that they want to say that okay, I want a longer lifetime of the network. So in that case, they select the devices, intermediate or the relay devices, they have the more residual energy. If someone they have only 10% remaining energy, other devices they have the 50% remaining energy. So they select a path. Maybe also that path is the longer as compared to the shortest path, but at least they have the 50% energy, whatever the nodes we have selected, so that our network can survive 50% time. Here the node is the 10% remaining energy, that means their lifetime is only the 10%. So if you are working on the quality of service, first you need to define that what quality of services you want to take. Say for example, you want to take energy efficient, you need to select a path which consumes less energy. If you are working on the lifetime constraints, then you need to select the nodes which has the more energy. If you want to consider the less noisy, in that case, you need to select the node which has the less node or they have the less noisy node data in that case. So select the quality of services. Based on that, you can modify that matrix of the AODV or whatever the routing protocol you are using. NS2 is the good one tool for this type of testing or hit and try. That is the open source community. NS2, NS3 you can install and modify these matrices based on that, and you can very easily to check that whether it is working or not. Yeah. Yes, please.
Okay, sir, thank you.
So I hope it answered your question, Seema. Any other question? Yeah, so there are few questions in the chat box.
Okay.
And do you have time to answer them?
Bluetooth maximum range is 10 meter. How we can increase? See, we are not able to change the radio properties. So whatever the range is there, you can use, and only that you can make, that is the one query is that Bluetooth maximum range is 10 kilometers. Right now, Bluetooth range is more than that one, and you are not able to increase the range. Only that if you want a more range, that means you need to go to the more hop count sort of things. That means we are not able to direct increase the range. What about the issues observed in the wireless sensor network, such as throughput, efficient delay, etc.? See, wireless sensor network is not using for 5G, 6G. Right now, wireless sensor network designed for the lightweight, small node. They have the power consumption or they have the very limited batteries. 5G, 6G is for other purpose, not for the wireless sensor network. And data aggregation technique that we already discussed. That there are 3 data aggregation techniques. How to improve our Wi-Fi or Bluetooth range? I already said that. One thing is that Wi-Fi access point deployment is also play a major role to improve their range and the quality. If you put a Wi-Fi access point in a corner, you are not able to find out a good coverage. So when you do the placement or that means setup of the Wi-Fi access point, you need to set up in such a way so that you find out a good range. And another that recently, with the help of some study, we also find out the distance between 2 Wi-Fi access points also play a major role in terms of their communication range or their good quality range. And yes, these are some questions that we find out on the chat box. Yes. So my mail ID is there. I suggest that if anyone has some suggestion or some queries, then definitely please mail me so that we can discuss more about that. Yeah. Thank you. Yes.
Yeah, thank you, sir. And in fact, on 24th, that is Friday, sir will again be joining us. for discussing about the network and application layer protocols in IoT specifically. So yeah, at that time, of course, those queries can be taken. Any other question? I guess there are no further questions. So thank you, sir. Thank you for this insightful session of wireless sensor network, which has definitely created a background for Internet of Things that we are going to cover in this course further. So
Yeah.
thank you, sir. And thank you all the center coordinators for being there, and all the participants for sincerely listening to the session. And tomorrow there is some slight change in the session in spite of the hardware part introduction that was supposed to be taken by Professor V.K. Gupta, sir. That is being changed, and tomorrow we will be having session on data, physical and data link layer of IoT by Dr. Munish Singh. So that is a slight change I wanted to inform. Looking forward for the tomorrow's lecture, and hope all the participants and center coordinators will join us at sharp 2:30 tomorrow. And again, thank you, Dr. Hari Prabhat Gupta, sir, for today's session, and looking forward for your session on 24th. Thank you, sir.
Thank you. Thank you very much. Bye.
Thank you. Thank you all the coordinators. If you guys have any query, please ask. Otherwise, I'll wind up the session. Okay, so thank you, everyone. And I hope everyone will join tomorrow at sharp 2:30 p.m. So thank you so much.